Alright, for 5 we should have 1 and 5, and it is 5. Okay, your next number is 21. You have resources in front of you if you need help. Alright. 21, you should have 1 and 3 and 7, and it is composite. Alright, now they're getting a little bit harder. 50 is your number. What are the factors of 50? Alright, you should have 1 and 50, 2 and 5, and 10. And it is composite. 45. Use your charts on your name tags if you need to. What they're there for. You guys are on the ball. Right, 45 should have 45 and 1, 3 and 15, 5 and 9, and it is composite. 52. Go ahead and finish 52 and then we'll move on. does that mean? It's even, right? Alright, you should have 1 and 52, 2 and 26, and 4 and 13. And that makes it composite. Alright, raise your hand if you know how long a meter is. Okay, well, there's a fancy little meter stick up on the board. This is a meter. It's a little bit longer than a yardstick. So I want you to estimate if you think your desk is longer. Is it more or less than 1 meter long? Just an estimation. You can show me on your slates if you want.
Wait, from the very tip of right here?
You could just go from this section.
Oh, man. That makes it a lot harder.
Some people think it's less. Some people think it's more. Alright, do you think Mr. Munkin's desk over there is more or less than a meter? Alright, now can somebody raise their hand and tell me why you think it's going to be what you put on your slate? Why do you think it's more or less than a meter?
Because it looks longer than the meter stick on the board.
It's a good observation. Anybody else have anything different? And how they estimated? No? Did anybody use any bodily measurements that might help? No? Okay, so there's a few bodily measurements that you can use to estimate whether something is going to be as big as or smaller than a meter. So a meter is about the width of a door. You see the door over there? About the width of the door. It's also from the tip of an adult's nose to the tip of the thumb with the arm extended. I think I'm short. Maybe Mr. Osmond could do it.
What's that?
The tip of your nose to the tip of your thumb. Further meter?
Still a little short?
No. That way?
It's way short, yeah.
Alright, and then it also says that a meter is about 1 big step for an adult. Obviously with long legs. I can't do that for you.
Close.
Yeah.
Close.
Mr. Osmond will have to demonstrate that one. I've got little bitty legs.
What was it? I'm sorry.
A meter is about 1 big step for an adult.
Right. It still seems a little short. Look, pretty close.
Alright, who can tell me why personal measurement benchmarks and mental images like we just discussed are important in estimating? Jacob. Did everybody hear that? Because you may not always have a measurement tool there for you to measure something. So going off of this, you could say, oh, well, that's about a meter. And then, does anybody have anything else to add to that? Why else would it be important to have benchmarks? We've been talking about benchmarks for a while now. We talked about it with fractions too. Why was it important to have benchmarks with fractions? Yeah, so you get a visual image of where it's gonna be depending on that benchmark. Okay, so in earlier grades, did you come up with a benchmark for a centimeter? Jacob? The width of your pinky? That's about a centimeter. Anybody else? JC? The width of your thumb? Do you have small thumbs? So it might be a little big. I think your pinky's a pretty good representation of a centimeter. Another one is the width of a paperclip. Have you ever heard that? The width of a paperclip is about a centimeter long. And then the thickness of a crayon. Who's that? Alright, so using your benchmarks that we just discussed for a centimeter, estimate the length of your desk.
All around?
Just the same part we did earlier. So estimate how long that part of your desk is using the benchmarks we just discussed. The width of your fingers. How many do you think it is? How many centimeters do you think that your desk is? Centimeters. Centimeters. Using what we just talked about with the width, the finger to just estimate.
Okay, hey, we got an estimate. 60.
We didn't talk about using rulers. You can't use rulers.
All of your numbers should just be an estimation. It doesn't have to be perfect because we're not actually using a measurement tool. I see some of the same answers. Good. I think we got a common few numbers, 150, 100, 200, somewhere in there. It's a good estimate.
90.
Alright, so early on you discussed that a flat of your base 10 blocks was the whole, right? And you were finding parts of that whole. Well, today we're going to use the meter stick as our whole, and we're going to be finding parts of a meter stick.
Guys, we'll put your slates down.
Alright, so base 10 blocks. What does each of these sections represent? Hayden?
1 base
1 base 10 block. Let's. Okay, if we put it up to here, how much does that represent? 10. So if it represents 10 in base 10, and it covers 10 of the meter stick, how much do you think each of these sections is worth? A centimeter. So, alright, I don't have the sticks up here. Do the sticks back there.
No, they're in that drawer. I think they're in
Which stick?
the
The name stick, it's fine.
Oh.
Alright, Alyssa, will you come put, I guess we'll do it down here, she can't see it. You can put as
Yes.
many of these longs that will fit that entire meter stick.
Miss Tuttle, I've got them if you need them. They're back here.
Oh, okay. Just put them up here. How many do you think it's gonna need? Okay, we just discussed, this whole thing is 10, right? And each of these sections is 1 centimeter, right? So how many of these will it take to make up the meter? Put them on there. And see how many we need. How many do you have up there? Alright, so she put enough longs, which are 10, on the board to measure up to the meter. So, if there are 10 longs up there, how many centimeters do we have? 100 centimeters. Alright, so if 10 of these longs equal 1 meter, what does one of these longs represent? I'll give you a hint, fraction. Heather. 1/10 of a meter. You're right. So, I'm going to draw a number line. In a perfect world, that would be straight, but I'm not perfect. Alright, so now we're gonna use cubes. What do these represent? 1 centimeter. Alright, we're gonna use cubes now. So if one of these equals 1 centimeter, how many do you think is it gonna equal to 100? I just repeated myself. Alright, so if we have 1 centimeter out of a meter, what fraction is that? Because there's 100 centimeters, right? We just did this. How many centimeters are in one long? 1 long.
10.
How many longs are in 1 meter?
10.
What fraction of a meter is 1 long?
1/10.
How would you write 1/10 as a decimal? Okay, there's a visual representation of what we just did. You guys are all right. So 1 long equals 10 centimeters, which equals 1/10 of a meter, which equals 0.1 of a meter, equals 1/10 of a meter. Alright. So represents 24. I need a volunteer to come up and represent 24 with the materials on the board. No one. You can just put them down at the bottom. They won't stay up there. Alright, can you tell everybody what you put over there?
2 10s and 4 1s.
Which makes 24, right? Thank you, Nolan. Alright, so we have 24 centimeters. And we had how many longs?
2.
2. How many number of cubes? 4. And what was the final length?
24.
In meters. So if we did one long,
24.
one long was how much of the meter?
10.
But what fraction of the meter was that? 1/10. So we have 2 longs and 4 cubes.
2 and 4 10.
Okay, we'll try this a different way. Represent 24 centimeters of the meter as a decimal. How many centimeters are in a meter? 100, right? And we only use 24 of that. You guys are on it. We all made it harder than it needed to be. Alright, let's try another one. Let's do 30 centimeters. Need a volunteer. Heather. She does pretty fast. Okay, Heather, how many longs did you use?
3.
How many cubes did you use?
0.
0. Okay, what is the point 30? Thanks, guys. You're on it. Alright, now let's go to page 95 in your math journal. You should see a page that looks like what's on the screen. 95. Okay, so in this table, you're doing exactly what we just did together as a class. Except you're not physically representing it. So complete the table to the best of your ability.
We have 0 longs and 3 cubes. How many centimeters is that? We just have 3 cubes. How many
about 8.
I just
And then
didn't hear
how
you.
much
You were listening. You were
does
playing.
that 8
We
represent
said
on
that
the meter?
one
There you
cube
go.
was worth
You
1
got it.
centimeter, and one long was worth 10 centimeters because we had 10 cubes in that one long. Okay? So if you have 3 cubes, how many centimeters does 3 cubes equal? Each cube is worth 1 centimeter. How many centimeters is that? What do you do? You have 3 cubes.
So if you have 3 centimeters, are you going to use your longs? We'll go over it as soon as.
One of these is worth 1 centimeter. This is 1 centimeter. Okay, this is 10 centimeters. We have 3 cubes. How many centimeters is 3 cubes? Alex, put it away. That's what we're using these. This is worth 1 centimeter. This is worth 1 centimeter. This is worth 1 centimeter. We have 3 altogether. How many centimeters is that? Where are you getting these numbers? You're just guessing. How much is this? 1 what? 1 centimeter. I have 3 of them. 1 centimeter, 1 centimeter, 1 centimeter. So how many centimeters altogether? 3. There's only 3 there, so there can only be 3 centimeters.
So this is 0.36.
So 3 cubes equals. Okay, write that in there. So what does that look like in a decimal? This is why it's so important for you to pay attention. Because you're not getting the work done. You're not paying attention. Okay, we have 8 centimeters.
Alright, raise your hand so I can tell who has that chart finished.
8 centimeters. How
Okay,
many
put your hands
longs?
down. Raise your hand if you don't have the chart finished. Okay, a couple more minutes and then we're going to go over it.
How many longs? These are cubes. Do we have a long out there? No. So how many longs are there? 0 longs.
It'd be 0.03.
How many cubes?
Because you only have 3 out of
8. So what does that decimal
You can, but we're talking about in reference to a meter. And a meter has 100 centimeters.
We have 0.3 meters.
We're gonna go over it.
So how many centimeters is that? Each one of these cubes is worth 1 centimeter.
Alright,
So if we
look
had
up.
12 centimeters, we would have 12 cubes. We have 30 cubes here. So how many centimeters do we have here? 30. How many longs do we have? 3. How many cubes do we have?
Alright, type your own answers.
0.
If you have a question, raise your hand and I'll come by and
Okay.
clarify.
We have 4 longs and 3 cubes. We'll go get 4 more longs. Oh.
I said raise your hand if you have a question. So I can clarify. Oh.
4 longs
on the bottom part of that.
Cube's 3. Okay, what's your decimal? You have 168.
I helped a bunch of them.
168 centimeters. Figure out how many longs, how many cubes have.
Alright guys, can I have everyone's attention?
I need all.
Everybody listen.
Okay, so for the second one in this table, I'm hearing that a lot of you are not quite grasping it. So if you have, okay, you have 3 cubes, right? So that just equals 3 centimeters, right? 3 centimeters out of how many as a whole? 100. So what is your decimal if you only have 3 out of 100? 0.03. Right? Because the hundredths place is 2 places, right? So you're going to have 2 places behind the decimal. 0.3 would be 30 centimeters. Does everybody make sense now? Clear as mud? Not clear as mud? That's the point. Alright. That's the point. Yeah, we're gonna go over the bottom part, but yeah, keep it going. Alright. Let's do number 2, 3, 4, 5, 6, 7, and 8. You can work with your face partner if you want. Or you can work by yourself.
Wait, can we work with?
Just work with your face partner for now. Or you can work by yourself. So you go ahead and start on your math box if you want.
Wait, which one?
The one's on 97. Okay. All of them just easy directions, math box.
That's 12 out of 10.
Math box, make a dot at 27. Okay. Make a dot at 0.1 meter. So we have 0.1 meter. That would be what out of 100?
We should do
We're done.
This is 10 out of 100. These each are individual centimeters. So the whole thing goes beyond. Will be, yeah, they start on their math boxes. Page 97. That's 15 out of 100.
base 10 volts. Make a dot at 4 centimeters.
Centimeter?
It's kind of another visual representation of what we did on the board. How much is this out of 100? It says So if it was point, if it was 0.01, that would be, so technically, yeah, that's okay. It would be what? Yeah, but it's 0.1. So it's 10 out of the meter. Yeah, so your V dot should be at 10.
Yeah.
Alright, raise your hand if you are finished with the page of the chart.
This is 3/10.
You finished with this page?
Let me double check.
You guys finished with the other page? Did you finish, Alex?
Make it dot 4 centimeters with A. Make it dot
Did you guys finish the other page?
centimeter labeled B. Okay, you have 1 centimeter. 1/10 of the meter.
6 and 7.
Alright, if you need to check your answers, here they are.
1/10. So what numbers in there do you hear that helps you? How many centimeters?
So, 0.12 is
How many centimeters in 1 meter?
greater than 0.09, right?
So you're talking about 1/10. How many of the longs did it take us to measure the meter stick? How many longs did it take?
It's not there.
Hey, did you guys already check the other one? Okay.
So it took 10. It took 10 longs to equal 1 meter stick. Okay, so 1 long.
Alright, everybody look up. If you are done with the page with the chart, flip over to the back of it and work on the page with the 5 charts.
Page 96 and 97. So it took 10 longs to equal 100. So 1 long equals how many? How many centimeters? How many cubes are in a long? 10. Okay, so that means there are 10 centimeters in that one long. It took 10 of those longs to equal 1 meter. So that means
I don't
1
know.
long is equal to
If
1
there's
meter.
are much bigger. These here centimeters is how much centimeters you put the meter, so those aren't big decimals. So I look up here, like in this one it says 10 centimeters equals 21 meters. So we have 0.23 meters. That would be,
2 meters. That means you have 2
it should
meters.
be 23 centimeters, right? Because 23 out of 100.
Alright, here's the first set.
0.23. See that? 23 out of 100.23. So you're not saying decimals, so it's just going to be 23.
You're done with the first set of tables. The answer comes up for you to check yourself.
Here this is saying 10 centimeters for 1 meter. So here we've got 10 centimeters is equal to 1. And yet that's one. It's about 1 meter. What is that number? That's what would you, what is the top? How would you say that? Let's put 0 on
Sure.
it. What's a better way of saying it?
References up here. 1,000 meters equals 1 kilometer, right?
What spot is that? 2 spots after this one.
Yes.
100. So 100. Right. And so if it's 100,
I've tried it.
what does that mean?
Because it gives you, I don't know.
It's 1 out of. Right. So if meter is 100, and one of those equals 10.
Well, this is look at this the same way we look at this, okay? This is 1,000 of this.
There you go.
Okay, so 1 kilometer is
You understand
1,000
that?
meters.
Okay, good. Same thing, look at, that's not
2,000 is equal
0.4.
to 2 kilometers.
Right.
So we're taking 0.2 of
Yes,
the
John.
kilometer.
Can we do the try to